Today we have a discussion on precast concrete. Many suspect the precast concrete industry began in ancient Rome, as the extensive network of underground tunnels that exist to this day seem to indicate the use of precast building materials. However, the documented history of modern day precast concrete industry began in 1900s when an English engineer by the name John Alexander Rowe, who discovered the precast concrete components could come together to build a structure efficiently. Rowe was first to get the patent for this process of creating precast concrete panel buildings. In 1950, the major precast concrete structure appeared in the United States, the Walnut Lane Memorial Bridge in Philadelphia. This bridge is recognized by many as the beginning of the precast concrete industry in the United States as we know it today. A few years later, the Precast Concrete Institute was formed to begin to set the standards for this emerging industry. Today we are going to discuss the following topics. First one, definition of precast concrete and its categories, advantages and disadvantages of precast concrete, and applications of precast concrete construction method. First of all, we have to know what is precast. Precast concrete is a construction product produced by casting concrete in a reusable mold or form, which is then cured in a controlled environment, transported to the construction site and lifted and set into the place. This is about the precast concrete. And next we are going to discuss about how it is manufactured. Precast concrete is created offsite using a mold. There is a main difference between precast concrete and site cast concrete, which is poured and its final destination on site. Here is a simplified overview of precast concrete process. First one, precast concrete is poured into a wooden or steel mold with wire mesh or rebar. This mold may also have pre-stressed cable if needed. It is cured in a controlled environment, usually at a plant. Once it finished, the precast concrete is transported to a construction site and put into a place. It's important to note that not at all precast concrete is pre-stressed with a cable reinforcement. The addition of this reinforcement is particularly useful in many structures and buildings where maximizing the strength of concrete is essential. The addition of the wire or rebar provides tension with the concrete, which is released once the curing is completed. The release of wire or rebar tension transfers the strength to the concrete, creating an even stronger material. Regardless of whether or not pre-stressing is a part of the equation, this process is faster, safer and more affordable than standard concrete. Precast concrete materials helps you maximize your project potential while making sure it is completed on time. They are also among the most versatile products in construction, combining a strong structure with the ability to choose any combination of color, form or texture, integrate facades, meet compatibility requirements for historic structures, create everything from small section to long open spans, be recycled or reused upon removal or replacement. These are some of the basic things about precast concrete. Okay, here the pre-stressed concrete technology can be implemented on such projects in two ways. First one, site-based precast plant, and second one, dedicated based precast plant. Then here we have some categories of precast building system. Depending on the load bearing structure, the precast systems can be divided into the following types. First one, large panel system, then frame system, slab column system with walls and mixer systems. First one, large panel system. Large panel system refer to multi-story structures composed of large walls and floors, concrete panels connected in the vertical and horizontal direction so that the wall panels enclose appropriate spaces for rooms within a building. These panels form like a box-like structure. Both vertical and horizontal panels are used to resist the gravity loads, and wall panels are usually 1 story high. Horizontal floor and roof panels span either as one-way or two-way slabs. When properly joined together, these horizontal elements act as the diaphragms that transpose the lateral loads to the walls. Then second one, frame systems. Precast frames can be constructed using either linear elements or spatial beams, column, sub-assemblages. The use of linear elements generally means placing the connecting faces at the beam column junctions. The beam can be seated on corbels at the columns for ease of construction and to aid the shear transfer from the beam to the column. The beam column joint accomplished in this way are hinged. However, rigid beam column connections are used in some cases when the continuity of longitudinal reinforcement to the beam column joint needs to ensure. Then next one, slab column system. These systems rely on shear walls to sustain lateral load effects, whereas the slab column structure resists mainly the gravity loads. There are two main systems in this category. First one is lift slab system with walls, and another one is pre-stressed slab column system. These are above the categories of precast building systems. Let's discuss about the importance of precast concrete construction in architecture. The construction is a time-consuming and expensive venture. Especially large structures could take years of construction simply to complete the exterior. In today's on-demand society, waiting years to complete a construction project, especially for much needed structures such as high-rise housing or parking ramps, just isn't an option anymore. Contractors needed to work as efficiently as possible while still allowing the designers to source materials that fit their vision. Before architectural precast concrete came to the market, the construction often required skilled workers to be on site in order to tediously build forms and pour the concrete. Not only was it costly necessity, but it also meant other work couldn't be completed simultaneously while the concrete was setting. Precast concrete enables the architectural panels to be made in large number off-site, while other construction tasks which can be completed on-site. This means buildings go up quicker and cheaper while maintaining the architectural integrity and aesthetic. A boom of popularity in the 1930s saw an impressive number of iconic buildings being made with precast concrete. Here we have some stunning examples of buildings made with the help of precast concrete panels. We are familiar about Sydney Opera House. This building is mainly done by using the precast building material. The next one is Pan American building. This building is also done by using this precast construction method. Let's discuss some advantages and disadvantages of precast concrete. Since the precast is manufactured in a controlled casting environment, it is easy to control the mix, placement and curing. The quality which can be controlled and monitored much more easier. Then it has good quality and entire building can be precast wall, floors, precast beams, slabs, etc. And less labor is required, and that labor can be less skilled. It is easy to make many copies of same precast product. By maximizing the reputation, you can get plenty of value from a mold and setup. The precast material which has high quality because of controlled condition in a factory. These are some of the important things about the precast concrete construction. The precast concrete structural members or precast concrete construction which has the disadvantages too. They have very heavy members, chambers in beams and slabs, very small margin for error, connections may be difficult, somewhat limited building design flexibility. Because panel size is limited, the precast concrete cannot be used for two-way structural systems. Economics of scale demand regularly shape buildings. Need for repetition of forms will affect the building design. Joints between panels are often expensive and complicated. Skilled workmanship is required in the application of panel on site. Cranes are required to lift panels. These are some of the disadvantages of precast concrete construction method. Let's discuss what types of projects use precast concrete. Perhaps the versatility is the most reason precast concrete structures are so diverse, ranging from parking garage, bridges and office buildings to stadium, retail shops and housing. It's clear any number of building types can be benefit from the advantages of precast concrete products. Some of the most common construction projects are explained below. The precast concrete structures are commonly used in parking structures, foundation, bridges, etc. In parking structure, design, durability, economy and installation are three key points of consideration, which is why precast concrete is usually the building material of choice. You will find several different precast concrete products in parking garages, columns, traffic barriers, stairs, paving slabs, architectural veneer and more. Precast concrete is useful for single level parking structures as well as larger and more elaborate mid-rise structures. The next one is foundation. Precast concrete is used to create entire building, more about the below, but in the cases where it isn't utilized for the entire building, it may still be used for foundation. Many residential homes and other buildings have precast concrete foundation regardless of what is used for walls and floors. In the rest of the building, its reputation for providing a moisture-free and energy-efficient basement is often what makes the precast the material of choice. The next one, bridges. The Walnut Lane Memorial building we already discussed, which began the precast concrete industry in the United States and using the precast concrete materials for bridges continues today. Some benefits of precast material. However, their benefits extend beyond the convince and workflow to include versatility, control, efficiency and sustainability, all of which come together to create superior precast. These are some of the types of projects which use the precast concrete and about the benefits of precast concrete. It's the time to wind up the section. Next section we will discuss another new important topics. Thank you.